In this episode of Finno-Ugric Machining we are dealing with this one. This is the Tailstock Quill lock mechanism, and yeah, it's not very good. First I will present what's wrong with that, and then we will do some lathe work, and then milling, and then again some lathe work. So let's go into the analysis. Yeah. So, I have attached it here quite securely. First of all, we have this vise, which I don't trust at all. And then we have a tool clamp, which is pushing it down, this workpiece. So we have tightened this vise, and then the workpiece is pushed down. So it means that it's aligned with the fixed jaw of the vise and the bottom of the vise. Furthermore, in the other end we have a big nut, and this big nut is very tight. Actually, I tightened it really securely, and then we have an adjustable parallel here under, which is then this nut is between this parallel and a tool clamp one more time. So this one, well, it's needed. This would vibrate if I wouldn't have it. It would give me a lot of chatter. So therefore it's needed. Okay, so there it is. We are going to set the X and Y axis. First of all, I have a thing like this. You can see it in the picture. It's just a, it's just a pin. But it has a very sharp edge, and therefore it is, I can use it for pinpointing. So what I'm trying to pinpoint here is I'm trying to align the axe of this one with the split line, so x-axis. So we need to I think we are there. Now I will lock this table for a while, momentarily, and then I will set this one for a suitable, convenient place. 10 maybe? Yeah, 10. There you are. Well, it's on 10, and then I will reset this dial as well. You need to take care of the backslash here, so that you always go to the same direction. Okay, X done. Next is Y. There you go. Next is Y, and this one needs, I have this edge finder here. This is a starret thing, a little bit more. So what we are going to find here now is this side of the workpiece. Not there. It's actually this is 6 millimeter in diameter, so we need to come this way 3 millimeters. Then we are at 0. So 3 millimeters. Okay. 1, 2, 3. lock it. And now I would also like to have this one. We have a scale here under, so I would like to have this. Well, it's I don't know why, but it's exactly on 10 at the moment. So nice. So, and then I just zero this one too. And it was this way, the backslash. Okay, Y is set now. Well, now we can change the tool here. Oh. I think that's enough. Okay. This is now the Wolhauter UPA3 boring and planing head. Well, it's the king of the boring heads. It's a really good device. Well, but you don't need to have this kind of thing to make an operation like that. Ordinary Chinese boring head would do as well, and even a fly cutter might be used here. Well, the fly cutter might not be applicable because we need quite a small radius here. It's only 40 millimeters, so the radius is actually 20. 20 millimeters, so the diameter will be of the quill is 40 millimeters. Okay, let me show you a picture about this like that. And yeah, so what I'm using here is the boring bar itself is carbide. It's really stiff. So this is one. Actually, this is a composite boring bar. It has a carbide shank, and then it has tool steel body for the carbide insert. So yeah, and there is a rhombic insert which has a very sharp edge in it. It's well, it's what it is. So our next step is to put the tip of this insert on top of this workpiece. On the actual operation we don't need that measure, but now we need it since we need to go to the halfway through for this workpiece. And yeah, so we first set the Z so that the tip is on top of the workpiece, and then we go 10 millimeters more to get half the way through of this material. The material was 20 millimeters thick, so yeah. We already have adjusted the X and Y. So Z is our next thing here, and this is just a scratching operation. Let's see now. So I could use here a feeler gauge in between, or the office paper, but well, this time I'm using just my senses here. Now we get it. So I'll zero this dial like that, and then now we are on top of that. So the next I will move this x-axis to the place where it was. So it was the backslash was eliminated this way. So I go over the point, it was a 10 here, 10 here, I go over past the 10, so I can come back to that real measure, which is the next possible 0 here. There you are. Now we are precisely on top of that So the X is now on top of that split. So I will now, we don't move the X axis anymore. So this is now done, over and done with X. So next step will be to move the Y. Now the diameter of that quill was 40 millimeters. It's a German thing, this 40 millimeters, you know. It's not like 39 millimeters or 43.5 millimeters. It's exactly 40 millimeters, and that's it. So yeah, we need to move this thing half of that, the radius, which is 20 millimeters. So we move it 20 millimeters, the table will be moved 20 millimeters that way. And in this case, the backslash was eliminated on to that direction. So it's exactly the wrong direction again. What we need to do, we need to go past the point and then come back again, because we need to eliminate. So this was locked, it's not locked anymore. So 20 millimeters is 5 turns on this one, because this is 4 millimeters per revolution. So 1, 2, 4, 5. And now we go past the 0 and come back a little bit, thus eliminating our backslash. There you are. And now we are there. And then we need to rise the table now to half of the diameter of this in order to get this tip at the center of the workpiece. So what we need to do now is to rise it. Well, it's 10 millimeters, so this is 1.5 millimeters per revolution, so it will be 6 turns plus 1 millimeter. So 3, 4, 5, 6 plus 1 millimeter. There you are. Lock it for now. Now it should be in the middle of and as you can see, it's a little bit too much. We need to, now what we are doing next is to, okay, we are going to, now it goes freely, and this is the last situation for you to check that you have clearance all over the place, which I believe we do have. Yeah, we have it. So now what I will do, I will actually just scratch here until it touches. Adjust the boring head. Okay. There you are. Now it's touching. Now we have set this quite exactly to 20 millimeters, the radius. Well, in this case we probably need a little bit more. I would like to have something like 0.5 hundredths of a millimeter more. So let's put 5 hundredths here. So we have and it's from diameter actually. So 1, 2, 3, 4, 5. There you are. And now, oh, did I? No, that, yeah, that was the correct direction. And then I lock this. That we don't touch anymore. We are quite ready to start milling this now. We have X is locked, Y is in correct place to start this, and then I measured the hole there, and it was we need to go 3.15 millimeters deep. Well, we have to be very careful with that one, because 3.15 millimeters would give us zero clearance. So we take a little bit more there as well. And then, well, we are ready to go. Now, the first pass will be 0.0 millimeters. 0.0, I mean 0.2 millimeters. 2/10 of a millimeter cut. And we will see how that does. So I already have the feed motor going on. And now let's turn this on. And then we just go up and see what happens. And to my eyes it looks to be exactly on the middle. And the surface finish. Well, it's okay. It's probably a good thing that it's not perfect, because okay, let's see now. We take another point. Let's take 0.3, because then it becomes 3.15. Okay, yeah. So 0.3 more, like that. Well, and the speed in this case is 240 revolutions, and the feed is 17 millimeters per minute. So I will come back when I have, it's the last pass. So we have 0.15 millimeters more to go. I will put a hair more into there, because I don't want to have that zero play there. I would have a little bit of play. So let's put first these 0.15. So 0.15. And now we need a little bit more. How much? Well, maybe. Yeah. Well, that's a good question. Here, that's the thing here. We put 1.18. That's then we have 300ths of a millimeter play there, and you know this is a floating device, so that should be okay. So the feed on. So this one on, and then we go. That's the final cut. So that's now ready. Now that we have finished the milling work, we have a good well, radius here. I already did some deburring and wiped it with this little piece of Scotch-Brite, so it doesn't have any sharp corners. I don't want this to mark the quill. It should be as smooth as possible, and it is. So now let's take the nut off. This is, well, it's quite tight. It should be. It was. It was very tight. And now, so now we should be able to take this away, and yeah, it looks like a really nice piece. And this one has a sharp corner. Let me show you. So this is now the upper piece, and this corner is razor sharp. But we will take care of that a little bit later. What we need to do is to take away from this shoulder. If I look at the original parts and compare these, so I can see that this is a little bit shorter. So it's about 2 millimeters each side we need to take off, and this is the original part. So we will take 2 millimeters off from that shoulder and 2 millimeters off from this shoulder. And yeah, then this should be done. And this, of course, is a lathe job, and we need a tool like this for that one. Tool like this. There you go. And then tighten this. There you are. So when I go inside like this, it stops at a place, and I put my 0 there. So I know how deep I will go with this one. So now I will take 2 millimeters off from that side and 2 millimeters off from the other one. And then I will round the corners a little bit, not a lot, but a little bit. And after that we will part this piece off. Well, after taking the 2 millimeters, I will pull it out and part it from the correct place. And yeah, but let's first take the 2 millimeters away. So now the next step would be to measure the depth, total depth of this hole, in order to determine how long should the underpart be. Well, the shop-made part that we had here, well, it's too short actually. You should have the maximum length there available, so it gets the best possible support. And now, well, of course you shouldn't make it too long. That's one thing. But let's see. Let's measure this one. This is easy enough to do. There we are in the bottom. Yeah, about there. It tells me 66 millimeters. Okay, if we take 1 millimeter away from that, I try to feel the edge down there. Yeah, it's smooth all the way. Well, I will adjust that later on so that we don't have a lot of stick out. This material is really hard cutting, so when parting off you should have a minimum stick out there. So let's see now. When I put this into here, so the total length like that should be well, should be what? 66 like that. So if I cut it now there, it probably is 2 millimeters too long, because I already took 2 millimeters away from that lathe. So we will put 64 millimeters there. Right. Old eyes, 64 millimeters like that. So now we know, and we can also check it like this. Let's pull this a little bit more away. So, well, the stick out is a little bit too much. I think there is a good place for that. A little bit more this way. Okay. And then we tighten it here. Let's see the clearances. These are okay. So this is way too fast. Let's put the back gear on. That's okay. Now I still would like to have it a little bit lower. That one. Oh, this is quite a lot. It might resonate. So it's so small that maybe I can, yeah, I will wiggle this off. So it's easier this way for the lathe. Well, yeah. This is so funny. Yeah. So that's a very good sound, I would say. So the nibble must be dealt with. approaching the moment of truth. So this workpiece is now really nice looking. Soon we will see whether it's only nice looking, whether it works or not. At least the fit is really good into that hole. So let's put it in place. I'll take this, right, I believe that's, let's see if we can put it there. Yes, we can, like that, I believe. Okay, at least it went down. Uh-huh. Okay, and now if I tighten it, locks really well actually. Yeah, it locks. Yeah, and then does it loosen up like that? Yes, it did. So this one doesn't bind. Well, it looks to be really, now it's a working solution. So what I would like to have here is a brass washer between those two. So after that we are finished with this one. I made this little bushing. It's just like that. Nothing fancy about this. It's just, but it probably makes a big difference here. It goes, well, let's see if it fits. Might be, because this is now 10 millimeter hole, so the correct hole would have been 10.5 for M10 bolt, but I want it to be precise fit. Let's see. Well, it goes there without any problems. So now we should be a lot nicer. Let's see how it blends in. Yeah. Yeah, it's really, and and it also medicates, yeah, it's locking now. So, and now not locking. Let's tighten it really hard. Yeah. And it's not binding because this thing is going down when I release it. So probably this is now correctly done. That's what deviates here from the original design. They didn't have this brass washer there. I like to have it there. It's sort of makes it a little bit gauzy. Okay, so this was the quill lock for your tailstock. So, in the next episode of Finno-Ugric Machining, well, let's see what it will be. I don't know, but as always, I will figure out something. Till then, bye!